We have three different types of functions: linear, quadratic, exponential. What I'm about to write is the exact formula for each, which is on your formula sheet. Okay? On your formula sheet. What page is that in your notebook? 3. Thank you, Addison. It's also what color?
Pink.
Hot pink. In fact, turn to it. Let's practice. Turn to it. It's also labeled on your formula sheet. Like it straight up says linear functions, quadratic functions, exponential functions. The linear one, if I'm not mistaken, I'm trying to pull this down. There we go. Where's the last one? Linear, mx plus b, right? Quadratic, Allie, how many are there for quadratic? 3? Will you tilt your paper where I can see it? For quadratic, they tell you there are 3 versions. I really don't like what they call it factored form when it's actually intercept form. But that's okay, we'll go with it. X minus R, and what's that other one? X minus S? And then exponential, thankfully, only has the 1. Right? You with me? We've already gone over this, but let me show you some mnemonic devices to help you. First of all, I'm going to change the word linear so that the first letter is not a capital L. I'm going to make it a lowercase l. Why do you think I made it a lowercase l? What can you tell me? What's a way to remember that linear forms a what shape? Huh? Straight line. Why do you think I made that lowercase l? Because a lowercase l is a line. You could also think of it as the number what? What number does it look like?
1.
It's a number 1. And the reason that would be helpful is because linear equations are to what degree? 1. Okay? See the connection? I'm going to make it into this type of a 1. If you had a table in front of you that was linear, which number of differences would match? First, second, or none? If it's linear, which differences would match first? Which is perfect because what's the degree? 1. So watch this. Okay, so I'm going to change colors. 5 to 4 is what? 5 to 4. 5 to 9 is plus 4. 9 to 13, Jax. 13 to 17, Bo.
4.
And what do you notice about this? They're all the same, and that's the first set of differences, so it's linear. Moving on to quadratic. Somebody in second block, Luke in second block, pointed out in a quadratic, in the word, he sees the graph. Think of what a quadratic looks like. What letter in the word do you think he is talking about when he said that letter is actually the graph of a quadratic? What letter? What letter in the word quadratic looks like the graph of a quadratic? What? The U. Now, I know it does have the little tail over there. Ignore the tail. It's a quadratic. Right? Because a quadratic is this type of a graph. Or this type. Yes? Okay. So there's a mnemonic device to remember that the quadratic is the U-shaped. Let's look at this. What if it's a table? Let's do... Okay, let's work on our differences. How do I go from 0 to 1? 1 to 4. 4 to 9.
5.
Is this linear? Negative. Which means don't keep going. Come on now. Come on. It is not linear. So don't say it's 1 and then run with it. I meant to say let's keep going. Here we go. 1 to 3. 3 to 5. What do you notice? Now it's the same. So the second differences match, which makes sense because a quadratic is degree what? Quadratic is degree what, y'all? Jackson, stay with me. What's quadratic? Degree? Yes, Bo. Phone a friend. Let's call him Jackson. Look at the different ways a quadratic could be written, though. You might be thinking, okay, I see the degree 2 here and here, but I don't see it down here. How many x's do you see, though? 2 of them. When you multiply this out, what's x times x? X squared. So that's where the degree 2 comes from. Exponential. Watch this. Couple of things. Hope you're listening. X in the exponent place, right? X my husband never calls me. Exponent place, okay? Couple of new things. Watch this. What is the math symbol? What does X mean in mathematical operations? Multiplication. Which means your table is no longer, spell it right, Ashley. Your table is no longer adding or subtracting the same number. Now it's going to have a common multiplier, okay? Another thing to help you with the graph is the L on the end. I want you to think of capital L, because what's the shape of an exponential look like? It's an L curve. Now it could be opening down, but that's still a general L curve. Okay, so now let's look at this. Let me make up some. I'm going to do 2 to the x. All right, here we go. So you come over here and you look at this and you should think to yourself, okay, 1 to 2 is plus 1. 2 to 4 is plus 2. 4 to 8 is plus 4. 8 to 16 is plus 8. Did not match, so it's not linear. Then you might say, well, it could be quadratic. 1 to 2, plus 1. 2 to 4, plus 2. Houston, we have a problem. I don't even need to finish. Second difference didn't match, so it's not quadratic. So let's take these off, and let's come back and let's see could I have multiplied by something? Now, let's say you're not good with numbers and you don't recognize what you're multiplying by. Go to your calculator. Do the second number. Now that you know it's multiplying, do the second number divided by the previous. Leave it. Repeat. Third number divided by the previous. Leave it. Repeat. Fourth number divided by the previous. Leave it. Repeat. What do you get the whole way down? 2. This is times 2, times 2, times 2, times 2. Oh, look at that. What's that X stand for?
Multiplication.
Thank you. Which means what function? Exponential. Which means what's the graph? No,
L curve.
L curve. Which means it has a common difference, sum, or multiplier. Multiplier. Okay? So I'm going to leave this up here. You are going to do the Desmos card sorting activity. I really needed that. I need to put something else on the board. Okay, yeah. I'll leave that up there for a second. Now I'm going to put that in your notes. I don't know, it may help. But I want you to do the card sorting activity. Now, the cards are a little big. Let me show you a trick for dealing with the cards when they take up too much of the screen.